it's time for us to continue. I guess to introduce Mr. Colp, a man who probably does not need much introduction, but I've known him for a very long time. He's the current project lead of the Asterisk Project. He is quite literally a man of many hats. Because I think every AstriCon, I think there's a different hat, which I love seeing. And he's going to be talking to us today a little bit about transcription integration with AI. Is that correct? Did I get it right, Josh?
Yes, you did.
All right, the floor is yours.
Yay, the floor is first to the video. Yay, it's me. You can clap if you want to clap. That's fine. So before we get started on transcription and AI, I'm going to talk about some fundamental stuff in the way that Asterisk works, just to give better insight into things. So let's talk media. Media is something we use every day. So what is media? Audio, video, and other things such as yield facts, which one day may go away, probably not. May be compressed using codecs or other mechanisms. May have other information attached. So in the case of RTP, we have timestamps for timing, sequence numbers, so we can see if they're out of order. But generally, in the case of Asterisk, when people talk about media, that's really talking about audio. So what is media in Asterisk, though? How many people have heard of an Asterisk frame? A few people. So inside of Asterisk, we move media around using something called an Asterisk frame, which is just a representation of it. These frames are used for many things, not just media. They're also used for things we take for granted as well, like DTMF, or ringing indication, progress, that kind of stuff. In the case of media, generally we also include the data payload, which is the actual media itself, and then optionally other details like the timestamp and sequence number that I mentioned previously. And really this is how Asterisk fundamentally works with media. So everything uses these Asterisk frames. The applications like playback, record, dial, channel drivers themselves, so PJSIP, EEX2 if you're still using EEX2. Anyone still using EEX2? Hey, we got 2. As well, these frames can then be used to construct protocol-specific payloads, such as RTP. So RTP is pretty much what the world is now, used in WebRTC, traditional desk phones, mobile phones. And the ResRTP Asterisk module is what handles RTP in Asterisk. We do have a pluggable model so that if someday we wanted to replace our RTP stack for some reason, we could do so. And ResRTP Asterisk takes the RTP in, strips away certain details, and turns it into an Asterisk frame. This only ever happens at the edge of Asterisk, so as it exits or leaves. RTP generally doesn't flow through Asterisk. There are cases and optimizations that exist where RTP can kind of bypass parts of Asterisk. In certain cases, such as if you are bridged two channels together, they're the same codec, don't really need to look at anything, then we can just kind of bypass the Asterisk frame whole thing and just kind of ship RTP directly between as an optimization. So let's look at the flow of media from a channel. Media is received in a protocol-specific way inside a channel driver. So in the case of ChanPJSIP, it leverages RTP. So in that case, it's actually ResRTP Asterisk that receives it, examines it, turns it into an Asterisk frame. That frame is then queued up and flows through the Asterisk core. And what is handling the channel receives that frame. So some examples would be app dial, so it can, well, technically bridging, so it can forward that media along to your other call leg, or record if you're recording a file. So it gets used in whatever manner is really needed. The Asterisk frame is then freed, and that happens over and over, generally about every 20 milliseconds. SDP does allow that to be changed and negotiated. So fun fact, for cases where you want to reduce the overhead of UDP headers, you can increase your P time, it's called. So instead of every 20 milliseconds, you can do it every 60 or 80. So it's less packets going on, which generally is less traffic overall. So the flow of media to a channel. So what is handling the channel? Writes an Asterisk frame to the channel. The channel driver transforms that in whatever way is needed, such as RTP, and then the media gets sent out. Some nice core features of just the way that frame handling actually works out. The core will handle transcoding for what is handling the channel, and the core also provides a mechanism, which I'll talk about here in a bit, to inject some custom logic into the media path for a channel. Example is mix monitor. Chan Spy would be another one. So how can we ship audio around for usage? When I'm talking about usage and this whole transcription AI stuff, I've broken it down into two usage cases, so active and passive. Active is what I call the channel is executing something, and that something is focused on the media that's going on. So the examples are playback and record. The passive case would be something's going on with the channel, it's off doing its thing, but we still want to know what's going on with its media. So the examples being Chan Spy and Mix Monitor. They're not directly handling the channel, they're just getting a copy of whatever media is flowing through the channel. So they can record or spy as appropriate. So when it comes to transcription and AI, let's look at the options. There's always writing a custom C module. The core provides all the building blocks needed to get access to do this. In practice, how many people want to write a C module for this? Oh, I saw one slight hand up. Writing C is hard. Everyone, it's just the way it is. However, it does exist as an option. So it's a way to do external media or get access to the media and ship it off however you want. So a dial plan application can be used for the active part. You're going to get all the media coming from that channel, do what you want. And audio hooks, which is an interface inside of Asterisk, does what it says. It lets you hook into the audio in a passive fashion. You just get the audio that's flowing either bidirectionally, unidirectionally, whatever you want. However, the other thing is that how the media actually gets external, such as to a transcription vendor, totally up to the implementation in C, and not a detail specifically of Asterisk itself. A question: how many people knew that AGI can actually give you audio? 2, 3. So for those who don't know, AGI is a way in the dial plan that you can have an external application or script execute. Control of the channel is handed over to that outside process, and you're able to control the channel and do what you want. eAGI, or enhanced AGI, also ships you over the audio for that channel. So you can do what you want with that as well. And this is one of the earliest options of a way of shipping media externally from Asterisk. It's seldom used, rarely known, as only 2 people raise their hands. Does generally work though. So you control the format of the media you are going to get using the eAGI audio format dial plan variable. I'm going to throw out here, in the future, probably whenever I talk about AGI, I'm going to add in this warning and explanation. On highly loaded systems, if you're using AGI, and this includes eAGI, it can result in timing slips and audio issues. Specifically, a place where you would actually see this is if you have a conference bridge going on using ConfBridge, and your system is heavily loaded, and you execute an AGI, your audio in your conference bridge might become choppy for a bit. And this is just due to the cost of executing your external application or script. Starting that process is just very costly in that scenario and does affect timing. So if that comes up, just something to note. Something else to note, how many people know about fast AGI? Hey, more than eAGI. That's excellent. So fast AGI, instead of executing an application or script, it just uses TCP/IP. It establishes an outgoing TCP/IP connection to some other thing. The act of sending media over that is not supported on fast AGI. Just a heads up there. So Asterisk has had a speech recognition API internally for a considerable amount of time. It was one of the first things I wrote when I joined Digium long, long ago. It's not for arbitrary use. It's specifically for speech recognition. It's a C API internally, so it's more C code. So speech engines register, receive audio, and provide results. There are dial plan applications and dial plan functions available for dial plan usage, and there's no included speech recognition engine. It's just strictly an API that implementations can use. With multiple speech options coming on the scene, we looked at what we could do to better facilitate interacting with them or making it easier to integrate that speech API I just mentioned. So we came up with AIAP. And AIAP is an API that allows an outside service to do speech recognition. It's documented on the documentation site, docs.asterisk.org. At its core, it's JSON and WebSocket based. And really one of the driving things for it was to allow people to leverage outside vendor software development solutions to more quickly add speech recognition support to the Asterisk dial plan. As I stated before, though, it's just speech recognition. It doesn't technically give you arbitrary stream of media that you can do what you want with. You can be clever in your usage if you have an outside service that just receives audio continuously and just does other stuff instead of return results. But that is not the intent of AIAP at its core. This is one I threw in. Using SIP, technically you can ship a call off outside of Asterisk. If a service speaks SIP and wants to do AI transcription stuff, there's nothing to say you can't use SIP. No changes to Asterisk required. You can add some additional details and things using the PJSIP header dial plan function. However, it's SIP. SIP is complex, and so that inherently increases the complexity of it. How many people know about Unicast RTP and Multicast RTP as a channel driver? A few. So when, going back in history a bit, when phones started getting support for paging using multicast, we looked at options of best supporting that in a mixed environment of multicast and also regular phone calls. And so what we settled on was a channel driver you can call that just multicasts out RTP to whatever you specify. So in Asterisk dial plan, you could use page and dial individual phones that don't support multicast, and we'll just auto answer. And then you can also multicast RTP out to the rest. So there's nothing to say you can't use this mechanism for Unicast RTP to just ship audio out that way. You can originate a call out to it. Media that's sent out that channel just gets sent wherever you want, be it multicast or unicast. And you can set the format as part of the dial string. However, any coordination, orchestration, signaling for that is completely up to you. And this is actually what ARI's external media uses underneath currently. How many people have used AMI plus local channels plus ChanSpy? So I got 1, 2, 3. Yep, a few. So AMI originate can be used with Unicast RTP, local channels in ChanSpy, so you can passively ship audio from a channel off elsewhere. Something else that people use this general approach for outside of shipping audio around is whispering sound files into arbitrary channels. So you can just originate out ChanSpy on a channel, have it go into the dial plan and do a playback, and you're whispering in a pre-recorded sound file. However, this does have a few moving parts because you're now involving AMI, local channels, ChanSpy. So it's totally possible people do it, but it does require some work. So ARI external media. How many people use ARI, the Asterisk REST interface? I'm excited to hear that. I'm happy to hear that. Following on from that, how many people like ARI? Yeah, that's cool. I'm glad to hear that. So for those who don't know, Asterisk REST interface, ARI, is a method by which you can write telephony applications outside of Asterisk using extremely simplified programming interfaces. One of the goals was to hide all of the nonsense that has to occur to do things from telephony developers. So a good example is you want to make a conference bridge, you create a bridge, you add in the channels, and you have a conference bridge. If you want to do DTMF stuff, you can receive events for that and then do what you want with those events. So it really hides a lot of the nitty-gritty internal workings of doing all that stuff. There is also ARI external media, which allows you to, in ARI, ship media externally from Asterisk to outside stuff. A nice thing is that this does provide a channel in ARI that you can just treat as any other channel. If you want to put it into a conference bridge, power to you. There's also other cool things, which I'll get to in a moment. Internally, it uses that Unicast RTP that I mentioned, but generally, you don't have to worry about that too much, except for your service that will have to understand RTP. It's nicer because it's all handled within your ARI application, and it can be active or passive. ARI Snoop Channels. How many people know about ARI Snoop Channels? Hey, we got 2. ARI Snoop Channels are kind of I like to think of them as I took the lessons I learned from ChanSpy and made a better ChanSpy. ARI Snoop Channels allow you to, as they say, you can snoop on a channel, you can whisper to a channel, but the nice thing is that an ARI Snoop channel is itself a channel. So you don't have to play around with the funky AMI plus ChanSpy plus local. For an ARI Snoop channel, if you wanted to inject audio onto a channel, you can create the Snoop channel and then call playback on it. And it will whisper in the playback, just like normal. So it can be used with ARI external media and a bridge to passively snoop on a channel and ship the audio elsewhere. Because they're both just normal channels. You just connect them together, the audio flows, and out the audio goes. So now that we have some base knowledge and some options, the inevitable question is, we'll get to it in a second. I'm jumping ahead. So Asterisk has many options for moving media around and using it, which is great for transcription and AI. However, I will freely admit and note, none of these do include direct integration with outside vendors such as Google or Amazon or any of the other ones that are springing up. Fundamentally, my goal in this kind of stuff is to provide the options and building blocks to accomplish it. Doing it ourselves within Asterisk can be problematic because we can't fully anticipate how you're going to want to use the information, how you're going to actually do things with it. That kind of goes into the area of trying to anticipate your business logic. We just want to make it possible to get the audio out and then giving you the freedom to connect it wherever you want, even to someone I've never heard of, and act on the results. So the inevitable question, what's best? That depends. Everyone hates when I say that depends. General recommendation is to leverage ARI and its external media functionality. It's the best option with what we've got. You can certainly use the other options if you want, if they better fit your scenario, but from practice of experimenting with things, this just generally seems to be the easiest to implement. Like I said, the other options can generally be more work on your part to put it all together. And I will also freely admit, this was actually a topic that Nir, who I don't see Nir, Nir was going to bring up at DevCon, but he wasn't able to make it, which was right now in ARI, the external media functionality can be a little unwieldy because it is underneath RTP. People would, there's better options or more easier options that we'll probably explore in the future, which I'll elaborate in my State of the Project update, such as shipping audio over a WebSocket instead of using RTP, that kind of thing. So in the future, I hope we get there, and I'm working towards that, but we'll see. So the general ARI approach, channel enters your ARI application. This is done in the dial plan by calling the Stasis dial plan application and passing it the name of your ARI application. You either do the active or passive usage approach, so using Snoop Channels or just directly interacting with that channel. Media is received into your ARI application as RTP currently. You forward that on to a vendor as appropriate, whatever vendor you may want. You receive the result, be it at the end or as audio is going on. And then you can take that result and send it elsewhere if you want. You can send it to ChatGPT or act on the result some other way. You can keep the channel in the ARI application, or you can ship it back to the dial plan and set result information as dial plan variables. Totally up to you which way you approach it. We just give you the option. So what can you ultimately do? You get the media, so it's really up to you. Some examples: live call transcription, IVR call routing with AI, live sentiment analysis of queue calls. So if a queue call is going on, you're shipping that audio out to sentiment analysis, and someone's getting rowdy, then you can raise an alert within queuing system, acting on other sentiment results as a call is going on. Per person conference bridge live text, that's also an option. Like I said, fundamentally, we're giving you the audio. If you can think of a clever thing to do with it, that's totally fine. Something else is that while I've mentioned transcription and AI, there's nothing to say you can't ship the audio out for recording purposes. If you want to ship it to another server and record it there, you can use this approach for that as well, instead of recording locally and then syncing it over elsewhere. Totally up to you. You'll note, though, this presentation is around live calls and live usage. And really, that's because for post-call, Asterisk doesn't provide you any value there. You can use an outside script when the call is ended to do your transcription or analysis or whatever you want then. Asterisk really shines when you have actual live calls going on and you want to do real-time media analysis, transcription, whatever it may be. So for post-call stuff, do it outside of Asterisk. Now, I have voluntold Mike to do a demo. Your other Mike. That is other Mike. Mike is on my team, so he gets priority as Mike. So Mike is now going to do a demo. Some context here. Mike was toying with all of this stuff a while ago. Basically given a research task to just like experiment, see what you can do, learn, that kind of stuff. So he's going to demo some stuff now. And I also gave him the option to do a, not going to call it that because of trademark, a demonstration which is potentially fraught with failure but may work, and we will see what happens. And it's totally at his discretion. Anyway, I'll pass it on now. Something else to add about this is that on the Asterisk repo on GitHub, there is an Asterisk -external-media repo with example code for this, an example implementation against Google written in Node.js JavaScript. So if you want to take a gander and play with it, that's a starting point. I will add that, I can't watch that. I will add, though, that it is demonstration code. It's not meant for production and stuff, so just a reminder, it's demonstration code.
Yeah, but we have, this is the AR method. There are some other sample apps we have, but this is the primarily, I don't know if you say recommended, our main way of getting audio off the box.
Yeah, and going back to what I talked about Snoop Channels and stuff, there's nothing to say you can't create multiple Snoop channels on individual, snooping on individual channels to identify specific speakers instead of feeding a single stream to the vendor and then having the vendor do this.
Figure this stuff out.
And trying to figure it out and getting it wrong at times. So it's all up to choices of how you do things.
Cool.
Anyway, questions?
It is streaming constantly. Basically what happens is those are the results that we're getting back as we go. So it's a constant stream that's going out, and then as the provider has an interim result, they send it back to us, and each line is an individual result that they've sent back. Yeah.
Yep, so it's up to the vendor.
Are there any plans on implementing SIPREC, or is this basically a solution to Asterisk as well?
SIPREC came up at OpenSIPit. Put it onto the potential list of things to do, but not currently in the future. If you have a exceedingly compelling reason for doing SIPREC, please file an issue in the Asterisk feature request repo so I can keep track of it. I don't think there's one there now. Yeah. Yeah.
Yeah, I think SIPREC breaks down the individual channels, and there's like a session. I believe there's an RTP session per audio stream, which is a little bit nicer. But then you've got the overhead of the sessions and transactions and all that kind of stuff.
Yep. Question. You gonna run? It's the vendor is DeepGram. The model is probably
Nova 2.
Yeah, Nova 2.
Nova 2 phone call. That's I actually noticed the diarization in particular with the first Nova model was like I was making it up. But with the Nova 2, it's a lot better. It's actually, if you even look at the percentages now, most of them are in the 90%. The previous models I've been using, they were more like 70, 80%. In this case, we're not. It just gets sent, and as long as the channel stays open, we keep piping stuff. And it's just taking the Unicast stream and copying it up to the provider. There's nothing in this demo that's... it's just the frame that we get from Asterisk. We just copy the frame and send it back.
So
out.
we're not making any determination or cuts or anything. We're just feeding it as we get it into the vendor, and then the vendor is sending back results as they decide. I'm sure different vendors will behave differently and may have configuration and stuff, but we're just going with, for the demonstration purposes, this is just straight up default with the upstream vendor. Question, Matt? Other questions?
This is just MuLaw, but you can use Opus, ALaw, there's a couple others. No, I've really only played with Mule and Opus for the most part. But I mean, again, any higher bit rate, it just, I mean, if you're getting this with 8K, it's pretty good.
Any other questions? Matt?
I know you said that this is just for a demo, but what Asterisk version do you think that this ARI transcriber might be available in?
So the ARI external media, which powers this, has been around for 3 or 4 years, I think, at this point.
Cool.
It's in all the modern stuff and some of the unsupported stuff. And the transcriber thing should pretty much work with, honestly, anything I think in the past 3 to 4 years. I looked at the repo for the ARI Asterisk external media, and I think the initial commit was 5 years ago. So seemingly we may have foresaw the need for this kind of thing. I don't know. It's funny how that works. So as long as you're on anything modern, you're good to go. If you're not on anything modern, you're probably still good to go to a point. Any other questions?
And this app, the ARI side of this app is actually, I think George probably did that when that came out, and it hasn't changed. So the only thing I had to change for this was the provider side. So that's been consistent.
Yep, it's continued to work.
Yeah, the WebSocket thing on there was for proxying the text results back out. So it actually can act as a server to proxy it back out. The provider in this case, we also use a WebSocket, but between this app and Asterisk, it's just a Unicast.
Yeah, it's just a Unicast RTP stream. In the future, I'm hoping to get it over a WebSocket, and I'll explain why that is the case in the Asterisk State of the Project coming soon, later today. Please stay tuned. Any other questions? Nope. Well then, thank you, Mike, for the voluntold demonstration.